Alright guys, here we go with the first problem. Leah deposits $500 into the account that earns 5% interest, 5% annual interest compounded quarterly. How long will it take her to invest her investment to reach 600? So for this one, annual interest compounded quarterly, we're gonna use our long one. We're gonna use the A equals P principal 1 plus rate over n, the n compounded how many times time. Compounded quarterly we know is 4, so we can just erase that, put in a 4 over here. Then 5% annual interest, that's your 5% annual interest, so that's what you need to put. Now 5% decimal form, has to be in decimal form, so put 0.05, move the decimal over 2 spaces. Principal, how much did we start? What was the initial amount? The initial amount she deposited was the 500. Erase that there, so you can put the formula down and then erase the variables and put in the key numbers. 1 stays plus that. Oh yeah, right, the n that came here needs to be included here as well. How much to reach 600? That is the end amount. That is how much Leah wants to end with. So what are we trying to look for? We're trying to look for this T over here. That's the important thing to look at. End amount 600, 500 initial, 1, that always is included, plus your rate, decimal form 0.05 given here. 4 is, we know from compounded quarterly. Quarterly 4. So that's what you put there. Then 4, and then obviously you put that again, T. So now what we do is, now to know how to do this, especially to find the exponent things, you need to know logs. That's in an earlier lesson of mine if you want to know. So actually watch that one before if this is a confusing step for you. So first of all, we want to put the logs thing together, and we want to put the other side together. So what we do to find out T is we first divide that 500 value over this 500 value over to 600. So what happens is you have 600 over 500 because we moved this over equals 1 plus 0.05 over 4 T. Now this is what it is. Now obviously we need to simplify this area here, so now we're going to put this in our great calculator, and if you were to put it in, you could put like 1 parentheses 0.04 or 0.05 over 4, or what you could do is find out this part, this fraction first right here, this fraction, then add 1 to that. And now it's important that you don't do any rounding earlier than your final answer. No rounding in any of the intermediate computations. It has to be in the end value. That's the only rounding. Everything else should be in its fraction form or whatever you can put it in. So try to put it in fraction form. And now one of the secret ways to do it with this great TI-84 plus CE calculator is you have this math button right here. You click the math button, boom, you have the fraction, just click enter, and what, 0.051 fractions? There you go, 1 over 20, the most simplified form you could get of the fraction. So that's a secret way if you didn't want to put the work of trying to find out the fraction of something insanely hard to figure out. So there we go, I solved it. Now it already comes out in a number that doesn't need to be put into fraction because there's no repeated, it terminates very quickly and is not a very long decimal, so I just put that on. So now this area right here has been put together, and now I'm just going to put an arrow to show the steps. 600 over 500 is 6 over 5, 1.2 for this part, 1.2. This is 1.2 here, so 1.2 equals 1.0125. Now, that is still in parentheses with the 4t. Now you might be wondering what to do. Obviously, if you don't know logs, back before when you learn this, right before learning logs, the secret to it is just guess and check. That is not what we're going to do. We're going to find the exact answer out. The way to do this is through logs. The simple way of doing it is we learn this one technique where we take out the exponent, like we have done with other things, where you divide to take out this 500, you divide the 500 to take it out. In the same way, we use logs to take out this exponent thing right here. What you'd use is your log 1.0125. That log cancels out with this exponent, boom, that's gone. However, this is an equation. This is not your, this is an equation. So that means it goes both sides. It has to go both ways. So now you have a log 1.01125 as your base, and you add in that 1.2 as your argument part. So that's on one side. And then this, because this cancels out, your 4t is what's left over here. So now what you get is you get log base 1.0125 and then 1.2, your argument, equals 4t. Right there. That's what you get. This part right here is this is your base of the log, this is your argument, and that. So now you're thinking, okay, how do we do this? Now obviously you need a graphing calculator for this, but what you can do is another thing that's in one of my lessons, the base change formula. The base change formula requires that you change the base into something that's common. Our common base is our log 10, or you can do your natural log. You can choose whatever. I'm just going to do log 10. I'm going to do that because I think I just like logs better than using a natural log, but it really doesn't matter. You can use whatever. So now how this looks is you have log. You're not putting a base because pretty much your base is 10, so I don't need to put this base 10. This is just as an argument. Log 1.2 divided by log 1.0125. This right here is what equals exactly this. This whole part right here equals exactly what's going on here. You change the base to log 10, and you have your argument 1.2 divided by the argument 1.0125. You get exactly this answer right over here. Then you do need to divide by the 4, so I would just recommend doing that over here. But the 4 equals t. Now put in your calculator exactly what's going on here. I'll show you the final thing that goes in here. You have your log button if you don't know what it is, log right here. You can use that log, natural log 10, or your natural log here, or your log 10. So log 1.2 divided by your log 1.0125 here, and this is part 1 of the thing. Enter that. Then you know that you have the divided 4 there. Divide your answer 4. Boom. Final answer right there. Simple answer. Now obviously the question should tell you where to round. This doesn't. So I'm going to do 10, 100, 1,000, thousands place. You can do whatever you want. So final answer T, putting it over here. I always put T and a little awkward. I don't do your normal classic, just normal, like straightforward, normal classic T, printable T, because it will start to look like a plus sign, and that annoys me, so that's why my T's are kind of awkward looking. So don't blame me for that. But 3 point from this right here, in order to see 3 point, put this in the, no, it doesn't come. 3.669 And then remember, you have to put your what is it, your units here, time. So the time is years. Final answer for this first question. Now I'm going to do 3 more and then we're going to finish. So this is the full thing. Just want to see this. Right here is all the work for this one question. You should pause it in the beginning if you want to do it yourself, and then check your answer to see if it's correct, and I have all the steps if you want to do this question. And I'll be doing 2, 3 more for you guys. Actually, I think I'll just, no, I don't think I'll do 2, 3 more. I'll show you how to do the compounding. I'll do like, yeah, I'll just do a few more. So I'll just show you. I'll go a little quicker with the next one because pretty much if you know how this is done, all we're going to do instead of using our full formula here, we're going to just replace this whole thing with E. So we're going to have A PERT. So the P, E, exponent RT. So that's our next question. So let's get that done and then I'll come back.